Welcome everyone to RIoT 49, the competitive edge. How edge computing takes business to the next level. I'm sure we've all heard edge computing as this buzz tech word, but what does it really mean? From latency to bandwidth, one thing experts agree on is that the majority of future innovation and growth will happen at the edge. Tonight, we're excited to hear from 3 experts to get their take on where edge computing is going. Like all of the 48 RIoTs before it, today is made possible by the support and partnership of RIoT sponsors. Because of their generosity and engagement in RIoT, we're able to bring you today's event for free and support entrepreneurs and economic growth across the U.S. So before we get to the main event tonight, a couple of things to put on your calendar. RIoTs 50 and 51 are coming up on February 23rd. Join us at RIoT 50 as we continue to explore DEI. At this event, we'll be examining accessibility through 2 lenses, the digital divide and physical and cognitive disabilities. Bright and early, on March 16th, we have an awesome event called Technological Innovations in 22401. At this event, we'll be hearing from some friends in Fredericksburg, Virginia, some small business owners and technology partners to hear how leveraging different kinds of technologies makes their small businesses fly. We ask everybody to keep your eyes and ears open for some exciting announcements from RIoT. We'll be launching cohort 7 of RAP soon, and the whole team is just blown away by this cohort. And last but certainly not least, if you're interested at all in augmented reality and love a challenge, you might want to follow us on social media at RIoT on Social. So how's everyone enjoying tonight's platform so far? Some of you may remember back in April of 2020, RIoT launched Mission R with the goal of supporting entrepreneurs who were actively working on a solution that addressed one of the many problems society faced during the early days of COVID. One of the teams that went through Mission R and a success story is Socialize. Rod, John, and Paulo saw that existing virtual platforms were missing an important factor, being able to network. They went to work to develop their own platform, and RIoT is thrilled to be able to help beta test it during the event. So thank you all for your patience and willingness to participate in a bit of customer discovery. The Socialize team is on tonight monitoring the chat for any bugs or questions you might have. So we ask everybody to play around, try out some features, and explore. After the event, we'll be sending around a survey to gather some feedback for the Socialize team, and we'd appreciate all of your support and participation. A few housekeeping items for the event. The main stage will be recorded and uploaded to RIoT's YouTube page. We ask everyone to keep yourselves muted during the presentations, utilize the chat window for any questions, and we encourage all of you to visit our exhibitor booths. You'll see them on the left side of your screen. Speaking of our exhibitors, thank you tonight for taking part in this, and please take a few moments to stop by. These are some great companies doing really amazing things. Now, what you've all been waiting for, let's get started with tonight's main event. Our first speaker tonight is John Cowan. I'm very pleased to introduce him. John is co-founder and CEO of Edgex. John is really Edgex's visionary and strategy leader. He has over 20 years experience leading early stage companies and developing talented teams. John, welcome to the main stage. Hey, John, how you doing?
Good. How you doing?
Great. Why don't you go ahead and pull your slides up? I just want to remind everyone that Edgex has an exhibit booth, so please stop by to learn more. And if you have questions for John, please put them in the chat box, and we'll get to as many as we can at the end of his show. So, John, take it away.
Great. Can you see my single screen okay?
You're looking great.
Awesome. Fantastic. Well, it's a pleasure to be here. Thank you so much for the invitation. I always enjoy going first amongst the group of speakers because it provides the opportunity to get as much out as you possibly can and set the stage for what I think is an important agenda to discuss around edge computing. So I'm pleased to introduce Edgex, which is a Raleigh-based early stage company focused on tackling the edge and all the challenges therein. I'm going to provide a little bit of an overview today of the way that we see the edge and the edge challenges and our unique approach to trying to solve some of those challenges for developers in the Internet of Things. So just to kind of set the stage as a bit of a reset, if you will, on kind of why we're here, it's helpful to kind of frame this as the way we describe the IoT, right? To us, it's the fourth internet. For those of us that are old enough, like me, to have built a career dating back to the early 2000s, it's kind of hard to imagine that anything could have had a greater impact on the industry than cloud computing, but we would be wrong. The cloud computing era was all about building internet-based software designed to connect the 13 plus billion odd people and things on the internet. But over the last several years, the nature of internet software has begun to change. It is moving out of the abstract world of spreadsheets and blogs and games and social media systems and platforms and into the real world. And in the real world, internet software is beginning to make critical decisions based on pattern recognition and signal interpretation and other things. And many of these decisions involve split-second timing that can mean the difference between things like profit and loss, wealth and bankruptcy, efficiency and waste, or even life and death. And it's when you see the future of the internet this way that you begin to develop an appreciation for the fact that IoT as a concept in an era is really going to dwarf everything that came before it. It will be bigger than everything that has come before it in the computing paradigm by orders of magnitude. Humans and human interaction will no longer be the dominant customer or consumer of compute and storage resources. In the IoT era, consumption is going to be driven by the connected apps and devices, and there are way more of those than there are humans. And that's what makes us excited to dig in and look at some of these challenges around IoT. So today, though, I mean, if we live in the world of here and now, what I call the third generation of the internet, this is how things look. This is how the world of web services and cloud computing kind of looks to you. Data and content is stored and served up to us in centralized cloud computing data centers. And through those providers or service providers or our own hardware or infrastructure, we're able to consume and do the things that we're even doing today, even this platform like Socialize, for example. For the era of web services, this works just fine. And for most things that I do today, I can tolerate the latency that exists between where I am on the internet and where the computing resources are that I need to use. And for this reason, the notion of cloud computing is likely here to stay for the foreseeable future. It works pretty good. However, there's a bit of a problem. In order to enable the next generation of internet software that I've described, high-performance computers are going to need to be located as close as possible to the things that generate the data and information that informs the models that create the events and make the decisions. And this is really where this concept of edge computing becomes super important. This notion that proximity matters, that I need to put the cloud as close as possible to where data is being spewed from sensors and devices and things all over the place, right? It's all the rage of late. Obviously, everyone's heard of edge computing. Latency matters a great deal in IoT, though, because we can't afford to have, say, an autonomous vehicle taking its time to tell the difference between a pylon and a pedestrian, which will require dependency on multiple real-time sensors, not just the sensors on board the vehicle itself. So to illustrate the gap that exists, I've highlighted some typical round-trip times in various AWS regions and called out the latest research involving, say, driverless vehicles. Their maximum latency tolerance is less than 5 milliseconds, whereas centralized cloud computing data centers are up to 40 times off that mark. That is a very big problem to solve. And so it seems easy and obvious and logical that let's just put cloud computing closer to where data is generated. If it's too far away, let's just put it closer to where data exists. That's our big idea, right? Well, the ambition of Edgex, which is highly simplified for the purposes of a vision statement, is to basically put edge computing everywhere within 1,000 feet of every connected thing. We think that a high-performance computer needs to be located that close to every connected thing, device, machine, what have you, that is creating data for processing. And so when we set out to solve this problem or tackle this problem, our first inclination was to just go back to what we know, the cloud. Right? Today, when most people hear the words edge computing, they think of something like this picture. The cloud is the center of the universe. It certainly is the center of my universe for the last decade plus. And the edge is more or less extending the cloud in some way to be close in proximity to those users and things. That's also the way that most architects have thought about the edge problem. That is, they've been working on extending the tools that we've been building for the last dozen years or so, virtualization, containers, Kubernetes, etc., and trying to make that all work at the edge. And in general, the way that we've tackled complexity in the cloud is with orchestration, right? You can take whatever name you like. There's a lot of nice names that people give these things, like schedulers or brokers or autonomous infrastructure or what have you, but they're all extremely complex. In the last 10 years, we've made great strides at improving orchestration. We know the names in the industry, right? We orchestrate database clusters, whether they're relational or NoSQL, et cetera. And we orchestrate our software deployments as containers and virtual machines. DevOps is wonderful. It's awesome. So it's natural that we want to take all of that work and all of that expertise over the last 20 years and build something better with better infrastructure at hyperscale and kind of just move it to the edge. But in fact, when we first started out our ambitious project at Edgex, that's exactly how we thought of the problem. So we're no different in that context. The issue, though, is that it kind of doesn't work, right? So there's a lot of reasons that we might say that today's cloud architecture is not a good fit for the edge. But speaking from experience, the root of those reasons is that the cloud's problematic key assumptions around centralization and permanence. Okay, that might strike some of you as a wrong-headed thing to say, maybe even sounds a little bit like heresy in the cloud, but it's something that brought us a lot of great agility, and we all love the cloud. But the notion of cloud is built on permanence. We build and deploy applications to static environments, even though it's this big amorphous thing called the cloud, right? But now we're talking about the edge. In the cloud, your data center doesn't move around. In the cloud, racks don't disappear in one data center and suddenly reappear in another. But that's kind of exactly how our IoT applications need the cloud to behave. It's when we examine this uniquely edgy problem of ephemeral, transient code and data that we begin to understand the nature of the beast, that the cloud architecture, the way we know it, doesn't really work under those constraints. From a developer side of things, we love the cloud. We want it to look like the cloud, but the gears of infrastructure that we've been used to, they have to be assembled and turned in a different way. And moreover, we need to maintain all that we gained from public cloud computing in the sense of multi-tenancy, right? We don't want to sacrifice that. So our first step to kind of solve for this distributed application development challenge is serverless, right? And we at Edgex are firm believers that serverless is going to dominate the IoT world as it becomes more the mainstay, because serverless is the closest approximation to how we actually build traditional IoT apps. They need an event developer framework. And that's what serverless gives us in a simple and beautiful way. It's an event-driven world. We don't need everything everywhere at all the time. We just need it where and when it actually needs to be there. And I think it's kind of wonderfully ironic that the ultimate cloud technology, serverless, invented by the grand poobah of cloud, Amazon Web Services, is actually going to be cloud's downfall when it comes to the edge, right? It's not to say the cloud is going away. I want to reiterate that, or disappear. In the next few years, though, what we think of as the cloud today, these big centralized data centers and infrastructures, are going to become a lot less important when we're building the next generation of apps and services at planet scale. So serverless is, we think, a big piece to solving the challenge of making it possible to scale apps at planet scale. But how do we actually make serverless exist and run without all the complexity? For guidance on this, it's helpful to remember the creators of the internet. And of course, I'm referring to Al Gore. If anybody denies that Al Gore created the internet, we're going to have a separate conversation, because he did. We're still using the technology that the creators of the internet developed over 40 years ago. They lived in a world of constrained resources. How did they make the internet work with such resource constraints on internet routers? Simple. Small is beautiful. They created protocols which could deal with state, and they made state really small. And that got us to thinking at Edgex, what if we could build something like a routing protocol for serverless that ran everywhere? And what if we could make serverless functions appear, execute, disappear in response to protocol states? What if we could do that same thing for data, right? With actual data. In other words, what if we built a truly distributed system, and instead of a complicated orchestrator the way that cloud purveyors would like us to try and do. This is exactly what EdgeNet does as an introduction. EdgeNet is our patented peer-to-peer content address storage network that uses a gossip protocol to make code and data available everywhere and anywhere. And by deploying EdgeOS, which is the Edge operating system stack, users can boot up and join any peer-to-peer network of computers and deliver the idea of a truly distributed edge cloud network. So I've intonated at one of the other challenges that exist in cloud at the edge being security, right? So back in the early days of our Edgex project, what we tried to do is borrow from the blockchain technology era. You know, we were fascinated innovators when it came to the blockchain era because of things like trustlessness and immutability. In fact, the first prototype of our EdgeNet platform was built using Ethereum as the underlying model to kind of decentralize trust. However, we quickly discovered that the consensus models that made blockchain so fascinating made it untenable for use to validate large volumes of data and code in any kind of reasonable time frame. It just wasn't right for, you know, the kinds of plumbing that would be needed to move and process lots of large volume data sets and code. And so that's why we designed something called Edge Notary. So just to kind of introduce this a little bit, if I have a piece of paper that I want to have validated in any court in the land, I would take that piece of paper to a designated human called a notary, and that notary is going to attest to the document's authenticity by placing their stamp and signature on the paper. We all know this. We've done this many times in interacting with the court system of the land. And that also got us to thinking that what if we could actually achieve the same thing but digitally, using code and data on the EdgeNet? So we developed this thing called Edge Notary, which, as the name would suggest, creates the ability for code and data to be cryptographically validated on the EdgeNet. Now, why is that important? Well, we think it's actually tantamount to solving the huge problem that IoT faces, broadly speaking, because, as we talked about earlier, IoT apps are taking on a much more serious purpose than traditional web services apps. And the last thing you'd want is for some nefarious actor to modify a line of code or take control of an autonomous machine or otherwise cause a disruption. So using Edge Notary provides a way for the developer to verify that the code and data executed on the network by a thing or a device or another code function is in fact true and has never been modified or altered in any way. Kind of preserves the value that we see in the era of blockchain without the performance hang-ups and limitations of technologies in the recent times. So before I wrap up, I'll just highlight a couple of use cases because obviously this is a lot to digest and it's still pretty high level, but just to kind of wrap your mind around, you know, where this goes and some of the things that we're working on here at Edgex that we think are very important IoT use cases. I'll first illustrate the work that we've been doing in the Department of Defense sector of IoT, the Internet of Military Things, as our partners like to call it. Our partners are using Edgex technology to build something that they refer to as the Edgex Federated Warfighter Tactical Edge Cloud, which is an amazing concept and term that just kind of rolls off the tongue. If you've spent any time in DoD land, you know that they like to come up with long-winded acronyms for names and things, and that's all good. But the idea is to take our entire technology on a geofenced basis and deploy it across a network, an edge net, if you will, that spans the HQ through the forward operating base all the way to the warfighter edge, the theater of battle, say, for whatever military group or department happens to be deploying an edge net. And the concept there is to solve the problem that the DoD faces, in that it's very difficult to get all of the advanced algorithms and solutions that they've created to be real time, to be highly tactical and useful to the folks that are on the ground, the boots on the ground, as it were. So an example of this would be, for example, gunshot detection in the field of battle. How can a warfighter tell in real time the difference between a car backfiring, a firecracker, and an AK-47? And how can they triangulate the potential distance or other vectors affecting a threat response? Well, to do that today is very difficult because the warfighter obviously doesn't have a giant data center on his or her back. So a lot of that solutioning, a lot of those intelligent algorithms have to be processed kind of in post-mortem. But by extending cloud services down to the edge across ruggedized compute form factors, what we can actually do is bring the cloud to the warfighter. All right, hence the federated warfighter tactical edge cloud solution that we believe and our partners believe is kind of part of the base of the future as we think about IoT in a military context. Finally, in my last few seconds here for the time I have before I'll take questions, I'll highlight another use case, which is a little more near and dear to us, and that is urban IoT. So, and specifically, I'll highlight one of our example use cases in traffic. So, by putting ruggedized form factor edge computers in locations like the street corner, for example, and deploying EdgeOS and federating a group of computers in an urban environment, we can begin to effect real IoT solutions involving connected and autonomous vehicles. And the solution that I'm highlighting on our screen here is real-time pedestrian detection, where in the classic IoT framework between sensor, processing, and actuator, we're taking video as a sensor data from a camera in an intersection, processing that on the edge net, comprised of those high-performance computers down at the street level, and producing information that's useful traversing V2X networks into heads-up display as a UX for connected and autonomous vehicles, but also into advanced predictive analytics for traffic control. We see these kinds of solutions as the future, for example, of things like EMS and traffic routing and traffic control, and even the identification of engineering fixes in dense urban environments, whether it's a sinkhole or a pothole or a downed light or what have you. So that's a bit of a mouthful, and I appreciate you guys being patient while I raced through as much content as I could cover in 15 short minutes. I'd like to thank you for your time, and seeing is believing. Go to edgex.io/beta, sign up today, and we'd love to expose our platform for developers of all ilks. Help us build the future. Thank you very much for your time.
Thank you, John. That was excellent. Really exciting to hear where Edgex is going. It does look like we have a few questions, so bear with me. So Chris, our Western Side Partnership Director, has a few really great questions. He wants to know, where can developers go to learn more about the Edgex platform? So
edgex.io is the first and best source to consult and get onboarded with our technology. One of the things that we covet at Edgex, like a lot of developers, is great documentation. So we've borrowed from a lot of our mentors, if you will, that have come before us in realizing that good documentation creates good developers and good experience. I would invite anybody to come to edgex.io, get in touch, and tap into our resources to help you learn and begin to build serverless apps, distributed apps.
Awesome. I see Chris put the link in the chat box, so thank you, Chris. He did have one more question. He'd like to know, what are the minimum system requirements for an Edgex Edge server?
So because EdgeOS is it's a free BSD build, so it is extremely small. I mean, we've deployed it on small as a Raspberry Pi. It is an OS install, so bare metal virtual machine doesn't really matter to us.
Okay. Gabriel has a question. What happens when a node is off? Will it get the data when it goes on again? Where is the data stored or relayed?
Well, so this is another sort of clever invention. Look. Yes, we invented the EdgeNet, but at the end of the day, we borrowed heavily from what we know and our experience in building the internet in the last 30 years. So the way that EdgeNet works is as a peer-to-peer network. So what happens is if one node drops offline for whatever reason, then code and data is instantly passed to the closest available proximal node thereafter, the next node in line, if you will. So that way, we never drop a packet, we never drop a job, we never create outage or disruption for the kind of code and data that is so mission critical in IoT.
So Tom wants to know, are you more competing or complementary to 5G networks and the embedded compute that will be in each of those network nodes?
Complementary. So if you think about, 5G is an interesting dynamic, right? So 5G doesn't solve the latency problem, right? So, a lot of folks say to me, well, yeah, 5G, well, I don't have to worry about computers at the edge or these kinds of things because 5G is going to solve that for me. The reality is that 5G is really just about bandwidth. It's not about distance. Whether I have the most robust 5G network or not, doesn't bear any consequence on the fact that I'm not solving for the speed of light. In other words, computers still have to be proximal to where code is generated in order to achieve those ultra low latency times for code response, for execution response. And so from that context, though, that it's very complementary to what we're doing, because obviously marrying an edge computer running Edge OS that's connected to a peer-to-peer network dovetails beautifully with anybody that's building a private or public 5G network.
So Mary has one question. She wants to know, what protocols do you use to receive and send data to the nodes?
Sorry, can you say the question one more time?
Yeah, absolutely. What protocols do you use to receive and send data to the nodes?
So out of the box, ATP, MQTT, pretty much any of your typical IoT protocols are supported out of the box to write data to the EdgeNet itself. But HTTP and MQTT are the two predominant protocols that we've seen in our early rollouts with enterprise customers.
Awesome. Well, John, thank you so much for being with us today. This was a really great talk. I enjoyed it a lot, and I know our audience did. One quick question I just want to highlight there, Amber. Somebody asked whether there's a relationship between Edgex and Edgex Foundry. No, there is not. Edgex, I one time, my CTO kind of slapped me for this, but at one time I was at an event and somebody asked that question. I said, no, we're not related to Edgex Foundry. We're the cool Edgex. So. Well, everybody remember that. These guys are the cool Edgex. John, thank you again. We really enjoyed it. And everyone, just so you know, we're going to take a very short break while we get our next presenter up and running. So feel free to test out the platform and visit some of our virtual booths, especially the Edgex one.
Thanks, Amber.
Take care.
Take care.